Welcome to the Black Belt session on programming the cloud using containers. Sounds like a lofty talk to me. Our speaker today is Sean Gillespie. He's a software engineer for Pulumi. His everyday coding is in Golang and Python, but his favorite is TypeScript since he's a stickler for correctness. He likes general purpose programming languages instead of YAML programming. He's a self-proclaimed, unapologetic programming language nerd. Thank you, Sean.
Thank you. Is my microphone working all right out there? Oh, it sounds like it does. All right, perfect. Thank you for the introduction. My name is Sean Gillespie. I'm a software engineer at Pulumi. And today, I'm going to be talking about programming the cloud with containers, which is a lofty title. But to talk more concretely about what I want to do in this talk, is that I want to build a cloud application together. Something that we've all done before, but I want to do a couple twists on it just to keep things interesting. I'm going to be running some containers as part of this demo, as we do sometimes. But what I also want to do here is we're going to build a reusable component, not just some infrastructure. So some part of our application I want to make reusable. We want to make something that is some component of our infrastructure that's also abstract, something that can be implemented in a couple different ways. And finally, when we're done, I want to have something that we've built together that we can package and share in a non-trivial way. So as we dive straight into this, I find that running containers is not, it's kind of a hard thing to do. I mean, for a couple of reasons. First and foremost is that composing containers is not an obvious thing to do this day and age. There's a preponderance of tools, Kubernetes or Docker Swarm or Docker Compose, different ways to compose containers together. And each is their own different set of tools and verbs and command line tools. And so it's not obvious how to proceed in these environments. It's also not easy to integrate with external services. If you're running in a public cloud environment and you're referencing things like managed services or external databases or the like, or things that are not in containers, it's easy to end up in scenarios where you have all of your dependencies passed in as environment variables to your containers, and it becomes this big mesh of just environment variables and things flowing through your code, and everything is very closely coupled. But the reality is that we all have to do this to run our production services. I mean, we all have to make this stuff run. And so we do this with tons of YAML, and we do this with tons of Bash. We have all these API objects, if you're familiar with Kubernetes, or just other things this YAML that describes how we want our applications to fit together in non-trivial ways. So I'd like to propose, what if we used something like a general purpose programming language for this task? We find that general purpose programming languages are well suited for the variety of other problems that we have in software engineering. So why not apply this to infrastructure as well? The code that actually makes your code run or puts your code somewhere else. Things we can do in a programming language that we immediately cannot do in things like YAML. We can share and reuse code just like we share and reuse the code for our applications. Sharing common infrastructure components and avoiding accidental copy-pasting of different parts of YAML or things that are changed slightly in one place to another, which is just too tempting to do. You can extract and encapsulate parts of your infrastructure. You can have things that hide their implementation details, higher level components built of lower level components that hide how they are implemented, so that people can't depend on your implementation details, and you can change them at will. They can be abstract enough so that you can have components that are not concrete, but instead are interfaces, things that can be implemented in different ways, in different environments, where consumers have no idea how these things are implemented. And these are things that are readily available to us when using programming languages that we just cannot do in things like YAML. So what I'd like to do for this talk is I'm going to be using a tool called Pulumi. This is the company that I work at. This is an open source tool. You can go check it out on GitHub. We also have our homepage is at pulumi.io, which has documentation. If you'd like to follow along on this talk, we host all of our documentation on this website. And all of our code for the actual command line tool that I will be using is open source on GitHub that you can go check out as well. But more concretely about the application I want to build in this talk. We're going to build something super simple. We're going to take a Redis data store and deploy it somewhere. There's going to be some Redis component here. And on my machine, on my laptop, I'm going to have an instance of the Redis Commander application. So I'd like to shout out to Joe Ferner for writing Redis Commander. This is just a simple web application for interacting with a Redis instance. But at its core, what I have here is a separation between my application, which is the thing that it will be Redis Commander, and my data store, which is Redis. And I'm being deliberately obscure about what this Redis is, because this Redis, we're going to do some interesting things with this Redis component in this talk. So let's go ahead and jump into a code editor. We start looking at some real code of if I were to build this application using infrastructure as code with general purpose programming languages, sort of what it would look like. So I'm going to hop over into my code editor right here. Is this a good size for the people in the back to see? All right, sounds good. So this right here is a program. I'm using TypeScript to write this program today, but if you're using Pulumi, you can use any Node.js-based language or Python or Go. I'll focus on TypeScript for this talk because it's one that I know quite well. But what I'd like to point out here is that what we've got here is sort of code that describes infrastructure, but it's still code. At the very top of this file, I'm importing a package that is at Pulumi/Docker. And this thing is it is code. It's just some JavaScript, some TypeScript that represents Docker API objects. In this case, I'm talking to the local Docker daemon running on my machine. But if you look at line 3 right here, where I have my cursor, I have this line of code that says const network equals new network docker.network. What this line of code is saying, this docker.network is a resource. It represents a Docker network on my machine. I'm literally creating a new Docker network by doing new docker.network on my machine. And here I'm giving it a name. I'm just calling it net. But this is where we're sort of melding the infrastructure and the code a little bit. On the next line here, if you look, we have a Redis image where I'm creating a new docker.remote image, which is just a reference to a image that I'm downloading off of Docker Hub. In this case, it's the Redis:/latest image. As I keep going through the file, I create a Redis equals new docker.container. Like here, I am literally creating and starting a Docker container through code in this program. I'm doing a new Docker container. Its image is the name of the Redis image that I just downloaded, which is Redis:/latest. It has a restart policy to restart on failure. And I'm attaching it to the network that I created in the first line of this program. So I'm attaching it by name through the network. So yeah, so I have this container that I've created. It's running, and it's running in a network. The remainder of this file is the application portion of this demo, where I am creating a new remote image for the Redis Commander image, which I'm just downloading off of Docker Hub. And I'm also creating a Redis Commander container. Like again, I am creating and starting the container. It references an image. It has a restart policy. It's attached to the network that I have created for my containers. And it has, as an environment variable, a reference to the name of the Redis container. And in Pulumi, we have resources that are the things that are created via new. They have properties on them that are outputs. They're similar to promises, and that they are asynchronously resolved as the program runs. So to refer to this name, the name of this container, I use this .apply thing, which is similar to .then, if you're familiar with promises in JavaScript. And with this name, I'm constructing an environment variable that tells Redis Commander the address of the Redis container, which in this case is just the name. And this is how my application is receiving a reference to my Redis instance. Finally, I'm allocating port 3001 on my machine for my application. And internally, Redis Commander listens on port 8081. And the final thing I have in my program is I'm exporting from the top level of my program a variable that I'm just calling host, which is a URL to my application. In this case, it's just localhost with the port that I just specified right here, 3001. So if I were to run Pulumi update on this program, what is going to happen is that Pulumi is going to run the program. It's going to record all of the resources that I created via the new invocation of a constructor for a resource. And it tells me first what it would do if I were to apply these changes. Now, I sort of lied when I said that we were literally creating a container or literally creating these resources. What we are recording instead is the intent to create these resources. And at the end, Pulumi keeps track of some state of the resources that currently exist, similar to other tools like Ansible or Terraform might do. And instead resolves a diff between the state of the world that you've expressed in your program and the state of the world that exists. In this case, since I've never run this program before, I need to create everything. So I'm going to go ahead and say yes, that I do want to create this network topology. And we're going to create some stuff. And here we're going through and we're downloading images, we're creating containers. And at the end, I have a single output that is just host, which corresponds to the variable that I exported, and a URL. So I'm going to click on it. And this is the application that I just deployed. So I can see here that it works. I'm talking to a Redis instance. There's a ton of data here. None of it's particularly relevant to my talk, although this application is super cool. But I just hope to convince you that this does work. Now this is all cool, but if you're familiar with other infrastructure as code like tools, none of this is super new. There are a lot of tools in this space that lets you do this sort of desired state configuration. What I'd like to do now is sort of explore what we can do when we use a real programming language to do this task instead of using something that is not a programming language. So since we are in a real programming language, I'd like to remind you that in Pulumi, we are projecting resources or things that have some sort of existence, like containers or images and the like, as classes into TypeScript and JavaScript. Since this is TypeScript, we can write our own classes, and these classes can also be resources. So for this next part here, what I'm going to do is I'm going to create a new file. I'm going to call this redis.ts, and I want to create a new resource. And this resource is going to be just code, and it's going to be it consists of other resources. And what I want to do is I want to write a component that hides all of the details about how my Redis service is implemented. Just that it exists. So I'm going to import the libraries that I need at the top of this file as Docker from. And so what a class like this would look like, I would say, I'm going to call this Docker Redis. In Pulumi, when you have a resource that is composed of other resources, you inherit from this pulumi.component resource class. This just tells the Pulumi command line that you're intending to wrap other resources by creating a component resource that exists of other resources. And the only thing that we used in our first program, the only public interface of this Redis component is a host. It's just some sort of network identity, some way to refer to the Redis thing. Whoops! Hope you don't judge me for my Vim fail. Oh goodness. Yeah, I'm really good at typing. All right, let's try that again. Now I have more time to talk because I'm really bad at Vim. Docker from Pulumi at Docker. Yeah, so okay, so before I failed that, Docker Redis extends Pulumi.component resource. So yeah, so the only thing that we need externally for this resource is its host. It's the thing that consumers connect to, and then when they talk to it on the Redis port, they receive something that can speak the Redis protocol, whatever that may be. So since this is a class, we have to define a constructor. And in Pulumi, all resources have a name. So my first parameter will just be a name. My next parameter will be some arguments, some object full of arguments. I'm not quite sure what this will be yet, so I'm going to leave this as any right now. If you're not familiar with TypeScript, this is just an arbitrary JavaScript object. We'll come back to this in just a minute. And finally, my last argument is just an optional object that in Pulumi, you can override some default options that come on resources. I'm not going to talk about this in this talk because we don't have time, but if you read a documentation or talk to me after the talk, we can talk in more detail. But for now, I'm just going to ignore that field. So the first argument of my parent superclass is a type. And this is just a thing that is just a user way to identify a resource just visually. I'm going to call this thing dockercon : docker : Redis. This is just to say, I'm writing this for dockercon. This is a Docker implementation of Redis. There's no particular semantics associated with this string. And I'm just going to pass everything along to my parent class. All right, so what we've written here is a class. It doesn't do anything, but this is a resource in our infrastructure as code setup. Like I can invoke this with the new operator. This won't do anything, but it is a resource. So now what I'm going to do is I'm going to copy the code that we wrote in our first thing here that does everything Redis related. In this case, it just takes an image and creates a container based on it. And I'm just going to paste it straight into this constructor. All right, and right away, we can see that my compiler is upset with me. In particular, it doesn't like what I've done with this network thing. In the original program, I had an identifier bound to network, or network referred to a variable that I declared already, but I have not declared anything called network here. And this is not a mistake. This is actually incredible. The fact that my IDE can do this because I'm using a real programming language means I don't find out about this when I try to run my program and it fails, or halfway through a testing deployment of my infrastructure and this thing falls over. Now that I'm using a real programming language, I get real IDE experiences. I get compiler feedback. I get real-time error detection. So since the compiler has told me that I need a network, I need a Docker network, I'm going to finally declare my argument type. I'll call this Docker Redis args. And I just need a network, which is of type docker.network. .network. And again here, see, when I hit dot, I get auto-completion for all resources that are associated with Docker here. And this is incredible. This makes my packages really discoverable. I can just walk in and see the sort of things I have available to me. This is just the sort of advantages that you get when you use a programming language to do these sorts of tasks. All right, so going back, I'm going to make my argument bag up here Docker Redis args now that we've decided on what this will be. And instead of network.name, I'm going to do args.network.name. Perfect. Now, the last thing we need to do here, we said at the very top of this class that the only thing we needed to produce was a host, a network identity that consumers can use to connect to this Redis instance. So in this case, like before, it's just the name of the Redis container. This.host equals redis.name. And, excuse me, there we go. We've written a component. What this thing does is it replaces the code that we wrote here that produces a Redis container. And now we have something that we can use like this. We can do Redis equals new Docker Redis that I'm importing from the new file that I just created. I'll give it a name, Redis. And I have to pass in the network that I've created. And there we have it. I have an additional problem down here. The compiler is telling me that I'm referring to a thing that this property name that does not exist on the class that I just declared. So I need to fix this up to say .host instead. But everything else is exactly the same. We've pulled out some of our infrastructure into a component. Now we can use the class that we wrote at the top level instead of referring to the actual implementations. And if I run Pulumi update once more, we'll see that now that we've changed our program around a little bit, but not a whole lot has changed actually. We've introduced a new component resource, but we don't actually need to change the base We don't need to change anything we've already deployed because the containers already exist. So now that we've built a component and it's reusable, you can do new Docker Redis in your code, and you can get a Redis running in Docker. But now, because we're using a real programming language, we can turn this into an interface. Like we said before, the only thing that we need out of a Redis service is a network identity, something that you can connect to and get something that speaks the Redis protocol. So let's have a little bit of fun with this. So instead of having Docker Redis be the thing that is exported by this file, let's define an abstract class. We'll just call this Redis, and this extends Pulumi custom component resource. Like we said before, the only thing that you need is the network identity. So we'll say this is abstract read-only host Pulumi.output of string. So anybody that provides an implementation of Redis must also provide a network identity. And since this is an abstract class, I must write a little bit of boilerplate to forward all of my arguments onto a constructor. So I'm just take a name, type and a name. Arguments, I'm going to call this thing Redis args, which the compiler will complain about, but I'll go back and fix this in just a second. Pulumi and component resource options. I'm just going to call super, type name, args, ops, and that's all we need to do here. As far as the Redis args type goes, let's just make this exactly Docker Redis args for now. This is a type alias if you're not familiar with TypeScript. We'll come back and fix this up a little bit, but for now, let's just say that the Redis component, we only have one implementation, and it's Docker Redis args. Also down here, let's do some more TypeScript stuff. Let's give our argument bag a type, and his type is going to be the string literal Docker. So in this case, the only legal value of type is the string Docker, which right now is not super useful, but you'll see in a minute that this is pretty cool. So here I get a type error because I've added a new thing. I can do type colon. There's only one value for this thing that I can be, and it's Docker. All right, so let's define a static method on this Redis thing. We'll call it create. It takes a name, arguments, Redis args, options, and let's just say that this creates a Redis thing. And the way that we decide what Redis thing to create is by switching on args.type. Now recall that args.type is the thing in the Docker Redis arguments bag that has type Docker. So at this point, since we only have one implementation, there's only one thing that we can create, and it's Docker. And here my IDE is telling me, yes, the only thing that we have, the only possible value of args.type is Docker. So in this case, we can return new Docker Redis name args options. All right, there's nothing else we can do here. But now, instead of this Docker Redis component now can extend just Redis. And now what we've done here is we've now separated Docker Redis. Docker Redis is an implementation, and we don't even have to export it anymore. Docker Redis is an implementation of the Redis abstract class using Docker. Now that we can do this, let's do it for Kubernetes. Let's have a Kubernetes Redis. Extends Redis. I'm going to copy up some of the boilerplate from here. The implementation of the Redis interface, which is the hosts, and the constructor here. I'm also going to define a new argument type. Exports type Kubernetes Redis args. Like Docker, this thing is going to have a type, but the type of this is going to be the string literal Kubernetes. And there are not any other arguments that I need to put in here right now. You can imagine that if I had 2 hours, we could do all sorts of cool Redis demos here with clusters and Sentinel, but I only have 40 minutes, so there's not going to be any arguments to this thing. So like our previous component, we're going to invoke our superclass, and this time instead of Docker::Docker, let's do Docker::K8s. And now let's create this thing on Kubernetes. If you're familiar with Kubernetes, you'll recognize some of the things I'm about to write as Kubernetes API objects. If you're not familiar with Kubernetes, I hope that I can explain sort of what's going on here. But the first thing I want to do is I want to make sure that all of the API objects I'm about to allocate have the same labels on them. Because labels are central to Kubernetes in a variety of ways. So I'm going to make sure that I'm going to declare some labels in a local variable that I'll then reuse. First thing I need to do to deploy Redis to Kubernetes is to create a deployment object in Kubernetes. So I need to first import a Kubernetes library. Now, like Docker, this is a library in Pulumi that is just JavaScript, but it is Kubernetes API objects, not just Docker. So in the same way that I could do something like docker.network, I can now do new Kate's apps v1 deployment. And this is a Kubernetes API object. I'll give it a name. As far as metadata goes, this thing is going to have a label, the labels that I declared above. Specification, this thing is just going to have one replica to keep things simple for now. Selector, it's going to be labels, like we are reusing the same labels everywhere. As far as a pod specification goes, these pods that it creates are going to have the same labels. And the spec of the pod, it's going to have one container. Its name is going to be Redis, and its image is going to be Redis:/latest. And this is the same thing as we were doing for Docker. I mean, we're just taking a single thing, one replica of Redis:/latest, and we're creating a deployment for it. In Kubernetes parlance, what we're actually doing is we're creating a pod that is running the container that I want to run. And so now I need to create a service object for this pod so that it can be accessed outside of my cluster. So that's the next thing I'm going to do. I'm going to create a new kates.core v1 service. Again, metadata, I'm going to put the same labels that I've been putting on all the objects that I've been creating. And then I will be, for specification, I'm going to have selector be the labels that I've put on all of my things. My type is going to be load balancer. The particular cluster that I'm speaking to is in a public cloud, so I can use the load balancer type. As far as ports go, there's only the Redis protocol operates usually on port 6379. Both my service and my containers are listening on the same port, so I'll just leave them at that. Next thing that I'm going to do here that I didn't do in the previous example, I'm going to say that these resources are parented to my current component. I'll point this out more when you see this when we run the update, and you'll see this in the command line. But this actually allows us to have a tree of resources. We have components that own their children, and you can see visually how your infrastructure forms a tree. So parent on this. Finally, the last thing we need to do for this component, just like we did with Docker, is provide some implementation of this .host. Since we're using a service in a public cloud, Kubernetes responds with a status field on my service object. This thing is going to have load balancer.ingress properties on it, and for the one port that I'm exporting, I just want the IP address. And that's that. That is the network identity of the service that I've just deployed to my Kubernetes cluster. So now if I go back to my original program, instead of importing Docker Redis, I'm just going to import Redis. Instead of new Docker Redis, I'm going to do redis.create, invoking the static method that I created earlier. And now I'm going to change this type from Docker to Kubernetes. And I need to make sure that I also add here the type of Redis args now can be Docker Redis args or union or Kubernetes Redis args. So now we have a type error in our program. So what we've got here is that TypeScript is saying, oh, you've given me something that has the Kubernetes type, but you also gave me a Docker network. That makes no sense. You can't do that. This is a type error. So, and this is, again, this is awesome. And this is part of why I like TypeScript so much, is that TypeScript lets you to express really rich type systems to allow you to enforce correctness at compile time of aspects of your infrastructure that you would discover later on in the process with other tools. So here we have type :Kubernetes, and now I'm just going to run Pulumi update again, and I'm going to pray to the demo gods that I can talk to my Kubernetes cluster. But if not, that's okay. I hope that I can still demonstrate what would happen if I were speaking to a Kubernetes cluster. It looks like that I have made an error here. Yes, unable to compile TypeScript. This is awesome. This is the compiler telling me that I've messed up. My function lacks an ending return statement. And in fact, it's telling me that this function is wrong. I created a new implementation of my abstraction, but I forgot to plug it in here. So I need to do case Kubernetes, return new Kubernetes Redis. Yes. And down here, this needs to be Kubernetes Redis args and not Docker Redis args. All right, so we'll run the program once more. The Wi-Fi is a little slow, but looks like this is working okay. All right, so we see here that it's now that we've tried to create two Kubernetes API objects, and you can see here that this is forming a tree where my dockercon Redis component has two children, which are two Kubernetes API objects. If I say yeah that I want to perform this update, then we'll go ahead and do it. We'll see that once I start creating these resources, we're actually going to get live updates from the Kubernetes API server on the status of these resources. My deployment has completed, and now my service is spinning up a load balancer, which hopefully doesn't take too long. Yeah, I'm going to go ahead and go back to my presentation while this runs. Yeah, so what we've done here is we've taken, using our programming language, we've introduced a new abstraction, we've implemented it twice, once using Docker and Kubernetes, and from the source program, it's really easy to switch between the two. Like you could imagine pulling this string literal being either Docker or Kubernetes from some sort of config system, like on your machine. Pulumi has a built-in configuration, a way to pass in configuration to programs. So you could say, yes, I'd like the Docker implementation, or I'm in production, I'd like to use the Kubernetes implementation. Now that we've built an abstraction, we'd like to share it. I'd like to reuse it. And this is the crucial step here. Is now that we have built something, we can share it. We can share it with people. So let's see if my Kubernetes cluster has. We are still trying to allocate a load balancer, unfortunately. But while this is going, before this talk today, I took all of the code that I wrote for this demo. And I published it to NPM. Oh, it looks like we've finally completed. All right, and there we go. After 1 minute and 36 seconds, we've allocated Redis on Kubernetes. If I go back to my Redis commander program, you can see here that I'm now talking to a Redis at 35.240.83.178, and this is a Redis running in my cluster. And it's talking to my this Redis commander application that it's just running on my computer in Docker. So yeah, so finally, to go back, I did publish all of this code to NPM prior to this talk. This is in the dockercon-pulumi.redis npm package. And this is just code. It's sort of like a radical thing, but since this is just code, I published it to NPM. I used it in this program. I didn't do anything special other than NPM's normal package release flow. But now I have this infrastructure component that I can use in my program to create real new real Redis instances on Kubernetes or Docker. And you can imagine using this code reuse mechanism however you choose to share code in your organization. You can do it almost trivially, and you're already doing this through your application code. So to recap over what we've done here, because we really did a lot in the past 30 minutes. We ran some containers, but we used code to do it. We wrote a program in TypeScript that, when run, produced a Docker Compose-like local setup of Docker containers. Then we pulled out some of our code about Redis. We extracted it into a class, like you would do, and then we made something that was immediately reusable, that we could just instantiate multiple times, just like any other object. Then we we used some of the real software engineering techniques that you would use in your application code to abstract our component, to provide multiple implementations of an interface, just like you would if you were writing an application. And finally, we packaged and shared our component using tools that we already use. There's no secret, there's no new tools, there's no ecosystem here. I put all my code on NPM, and I pulled it down using NPM, using regular package managers. So thank you so much for coming to this talk. It's been a blast being here to give it. I challenge you that if you're interested in what you've seen so far, you'd like to see some more, come check us out on pulumi.io. That's the center of all of our developer documentation. So you can download the Pulumi command line application that I was using. You can see all of the packages that we support. We support AWS, GCP, Azure, Kubernetes, many other cloud providers that you would be interested in using, and Docker, of course. All of the source for this talk is on github.com/swgillespie/dockercon18. If you don't believe me, all of the code that I wrote on stage here is on there, as well as the code that I published through NPM, which has some things that I did not have time to talk about here, which are some more implementations of the interface. You can follow me on Twitter at swgillespie or PulumiCorp at PulumiCorp to keep up to date on what sort of things are new. And I believe we have time for some questions now. Thank you. All right, any questions? Yes. Where do I keep state? So, okay, the question is, where do you keep state? By default, Pulumi stores state in a web service that we have at app.pulumi.com. When I was doing all of the CLI commands, it was constantly sending the state to the SAS server. We also have a non-default option where you can store it on your machine if you'd like, just as a single file. Both method of operations are fundamentally the same. Yes? Any other? Yes? Okay, so the question is, who is the intended audience here? If it's a developer that does ops or ops people doing developer tasks, we find that I feel like it's often the case that they're the same people doing two different tasks. That when developers do ops tasks, they feel like they're missed programming languages, and when ops people do developer tasks, I guess I don't need that anymore. When ops people do developer tasks, they find that they sort of end up in different worlds from the developers, or they're using different tools. I think that this is to answer your question more specifically. The target audience is both, because both people need to do these sorts of tasks, and it's very helpful to have a common language between the two so that people can collaborate. Any other questions? All right. Well, I'll be up on stage, and I'm doing the hallway track. If you want to come by and chat. Thank you all for coming.